Okay, hello everybody. Good afternoon. We are. Uh, just let me see. Just arrived on a city nearby Acapulco, uh, because I give assistance to my mother, and I wanted to dig into this topic right away, so I can have time to do the guitar as I have been wanting since forever. 3 hours, 4 hours of study, of practice different exercises. Yeah, and I'm donating 2 hours of my day to this application. And why donating? Because I have justified myself that this is for people wanting to do projective geometry in their mobile devices. Most likely there is software already available, but I wanted to have this also available for you all. I don't know what to click. Let us see first if we are live. Your videos and live. We are live. Let's click on Debian. Then click on this Debian folder. Then click on home. My name. My website. My name again. Playground. If this is confusing for you, if you have your name, then some other thing, and then your name again. This is uh, uh, um, is not that unusual in the Django development, and this was a casualty, some sort of coincidence. Well, I don't feel like anything, uh, something bad happening from this because in Django you have this same of naming convention. So geometry. Let's click on index and open with edge. And look at how beautiful this looks like. I like this. Look at this. And the screen is not messed up today. So we can appreciate the thing, the colors as they are, and it's only a flickering in the screen. Well, not as usual. Well, let's change directory to my website. It's okay. So, and we have this beautiful. We have a lot of code. Now it's time for us to try right away um, the stranded edge without making any more drawings because we are going to apply the same principles that we have applied for the rectangle. So we are going right away and draw some, draw some images. But I want to change this. I want to call it the straight edge one, because we have another here. A straight edge A. So let's be new image, new image. It's the same image, small, small. It's the same source. This is the A, and this is the B. Hopefully you are following what I'm doing. I am just renaming what we had already. What we had already. We had some ruler, but we are getting rid of that and renaming these things as straight edge because we don't have marks. This is a ruler, but it has mark, you know, to measure. But you can think of this site without the marks as a straight edge. If you're doing geometry with the book, you can use this without the marks, so you can see the invention of this instrument. That was amazing to see. It's amazing if mathematics is presented with the discoveries, or what they help to measure. I would like to study electricity, but in the context of the mathematics and seeing the effects of electricity. Not only drawings like this is an electron and this is a proton. So some circles with a plus and then another circle with a minus sign. I don't like that. I never paid attention to that thing. Only to pass the subjects, the semester. How do you say that? But I didn't care. I said, this is nothing. This is a bunch of drawing. There is no electricity here. But I would like maybe in the future to see the electricity, at least the effects. So the dragons have meaning. Oh, so this exists because it is representing this movement, maybe this force, this intensity. Other than that, it's nonsense. But then someone will say, well, then you will need to go the outer space to study, the you know, some exoplanets. I am not into that, so maybe it's good for you. I am not into that. I cannot know anything. It's good, but it's too far from here. But it's great if you are into that thing. Uh, it's great to to be able to see that in your mind. You have a big mind. If you're able to do that, maybe with the help of telescopes. So we have renamed this thing, no more ruler, more like a straight edge, which is an instrument. And then we have a straight edge with midpoint. We are defining these variables that we are going to get rid of this for the time being. Then we have current x, current y, which are related to the drag and drop effect. It's draggable. Draw. We are going to start with straight edge A on the image on load. Uh, we're going to draw the straight edge A in the normal, uh, in an horizontal way. We would like to draw a straight edge A as at, sorry, um, A So this is at 100, 200, sorry, 200x, 100y. We are going to draw the straight edge A here because it is a small image. So we are going here. So it will be something like 500, uh, 300. We are going to use this AX S from straight edge A from AX, the component X, 500, say 300. This is for the drag and drop, which will be a big time thing to do tomorrow, maybe on this week. Well, for now, let's forget about these things. Even from is draggable, those sacks, and say, now we should have a threaded edge, maybe. It's here, but it is lost. Why it is lost? It is lost because there is a canvas reset, and then on draw image new position here on new position, and we don't have it anymore. So we are going to let's see if we can. Yeah, these are like global variables if you like. So maybe we want to move this from here. We will optimize this code apparently. Let's go here, down here. It should work now, maybe. Okay, it's not working. We are okay. It seems like I am something is messing with my brain and having several ideas in conflict, which is not good. I want to be in control. So that reminds me of a new short for Veritas World that I haven't taken note. Wheel collision, a free wheel collision. Veritas World in which the apparatus send you an order, send send you an order to your brain, send an order to your brain when you detect the order on time. Uh, right before uh, the action you wanted. Oh my God! Look at this. They wanted to perform on the first place. Okay, so this is a new shot for Rita the world. Um, in this world, the citizens are getting screwed by this apparatus. They are being controlled. Without consentment, they are being assaulted in their will, right in their brain, without. They are on the, they are in the. They are not even equipped or prepared for these attacks. It's new for them. So imagine Berita wanting to do something, pick a plate from somewhere, and the apparatus immediately says, grab some So maybe what else? Uh, Open the refrigerator. They are still testing the apparatus. They are having fun with their jobs, because they are miserable and they need to have fun with to make their lives a little bit to fit in the pill, and they're having fun. They are enjoying their days. So there's orders like as silly as open the refrigerator. And Verita wanted to pick up a plate, so it's like it does not pick the plate and it does not open the refrigerator. So it says like this, and I will do in that animation of Blender, and it will be free will collision because Verita, well, not Verita, well, she's aware in the future, so maybe she's very equipped to deal with this thing, but she is exploring the past when this thing started, so maybe Smarty, the other character, will be doing like this. It's more suitable for him. So it isn't because that will be a little bit of comedy in this dark world with this guy. Having said that, we need to draw this thing, and it's not getting drawn. I was about to check the console, but then I said, let's tinker, tinker with the dwarfs, and put this thing here, and then look at the console. So we are still in charge. Okay, there's something happening over there. You saw it. You saw the ruler. You saw the strategies. Look at this. You're seeing it here. Something is happening here. But then it gets disappeared. So no errors. We have no errors on the console. So it's all about the drawing. Maybe the rotation. Okay. In here. So we draw the thing here. Now we can get rid of this. We are understanding at the same thing at the same time. And hopefully you are understanding too. Maybe I'm not sure. Most likely you are not following along because I don't have this code up there on GitHub. Lately, it will be the maybe a library on rotation. Uh, so before the rotation here, we can you can we can do it here right before the even the rectangle. Remember, we got rid of the. Now look at this. Look how beautiful this is. But now the color looks like. Uh, how to say that? I learned this word in. Maybe I will read again The Lord of the Rings. There were like a zillions of words new to me. But I really didn't enjoy the part, the description, as beautiful as it is, the forest of Ithilien. It was a pain for me to grasp the idea of that paragraph in this page. Oh my, it took me an hour or 2 hours maybe, one single page. A lot of unknown words to me. Almost the entire page was unknown to me. What I did, I translated word by word and managed to make an image of the place in my mind. I didn't put a lot of effort into imagining the place. So we have this. Now, We are going to draw the threaded edge B, which is rotated. Maybe we can rotate the threaded edge A. Maybe. Well, I'm not saying this right now. Let's see if we are able to draw a threaded edge B in a rotated fashion. We are going to reuse all these variables. Uh, we are not going to draw this magenta uh, rotation anymore. We are going to reuse all of these for the threaded HB. Maybe we will have a nested lambda for threaded HB to be loaded. But that's not no it's not ideal because there will be a lot of rotations. So maybe we for example for demonstration purposes this is good, but in real time there will only be a threaded HA. It's funny that we haven't had any internet interruption. Mm, 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 mm. Something like this. We're going to reuse all of this, and we are not going to do this. Okay, here it is. Mm, I don't know. Mm, I'm going to comment. Okay, no more rotation of the magenta. So now we are going to reuse all of these stuff. So for this x will be sax. For y it will be say. This is them for demo purposes. And we will. There is a lot of work we have to do. So now with that will be a set HA dot. Come on now, give it the width. Okay, width. Set HA. A cool. And then mid x is x, okay, and width, okay, over 2, and this will become variables or properties, computer properties on an object of a certain H object. A lot of software engineering that Python people love, especially the researchers. Uh, no, I'm not sure if I'm a good software engineer. I'm not sure if I am a good software engineer. I'm just procrastinating again by just talking without any fundaments, which is ignorant. Well, that's okay. It's not okay. Mid X, we have understood this, so we have the. It should work. It should work. Radius is the width over two. This should work as it is. Then we are translating. Then rotate. Now we should draw again. So this is no more. X with probably this is not going to work. We will need to understand this. We didn't read the code. We just tried to go in line, adapt the thing, we avoid uh, bring investing, wasting brain energy, and no errors. So let's print these two. Say we should work this part honestly, but we are lazy and we have quite a day. So let's print. Well, definitely we will, and read the code and adapt it accordingly. Sucks. Sucks. Say, see, it is printed a lot. It is printed a lot. It shouldn't be. There should be only one. No, 20, 91, 91. Uh, so something went wrong here. I don't know. I didn't want to read it, but we have to. And then maybe do some drawings in the black in the chalkboard, right? Uh, oh my God. Let's read code. It's almost 6 p.m. on this day. Okay, so X is sax, Y is A. Okay, sax, as you are seeing, is 500, 300. So X and Y should be these two. Okay, 500, 300. So far, so good. Now let's print this because we don't know what's really going on. Most likely in the book area, there is a way to see all the variables, so I really don't want to. So let's use space with, let's be very specific, we have a haze Ace. It has with 320, which is true. This is the width and height of the threaded edge image, if you remember correctly. Then we have mid X and this guy. So it should be 300 plus something, 150. Mid X, mid Y. And maybe in here you want to use like coding or some sort of artificial intelligence assistant in which you can say print the book, no, print in the console the values for with the voice, not writing. Right now, most likely people are doing prompting with text, natural language. Print in the console mid X and mid Y, and you will get this line of code, maybe, or two lines of code with console log. I'm not sure about this. I'm not sure about this. Most likely that is happening. What really will be cool and it will be possible in the future. Do not use your hands and say print mid X and mid Y in the console, and then you will get this line of code as an answer to your request. Uh, Switch to the web browser, and you will get this. Refresh the website, and you will get this. Right? That will be maybe they are targeting to that with these AI laptops. Uh, Something like this 650. Um, I don't think that's the case because 300 is the width. Uh, oh, 500. Also, yes, so this is great. This is cool too. These are correct. Okay. Now we are uh, going to bring C term X, C term Y. Y remains the same. Well, this move then, which is the height, over 2. So this is also correct. Now the radius, is 150, which is correct. So everything is correct in here. So we are now translating to C turn X and C turn Y. So with the translation, we are ending here, somehow, somewhere over here. I'm going to get rid of this. Somewhere over here. Somewhere over here with the translation. Now we are going to calculate this point. Uh, okay, now we have 0. We okay, beautiful. I immediately uh, when we reworked, then maybe it should be straightforward if we were uh, fresh in the morning after 7 hours sleep. That would be immediately obvious. Was oh, believe me, we were able to jump from here to here because we are making a translation over here and we are doing this thing. So it took us 36 minutes. Okay, now let us do some reflection. No more chit chat, Caleb, please. Someone might say. Uh, but I I uh, this is life, and I haven't scripted this thing, but I did think on this prior to being live, going live. Uh, mm, so 2 months ago, we were doing a lot of. They are not here anymore. Yeah, we were doing this. We were we performed a rotation, and we took note of the coordinates. We were uh, calculating coordinates, and we were doing some tabular. We were gathering some tabular data. Mm, mm, but then we accepted the reality. There were no relation. There was no relation, and we did have to accept the reality, or at least we couldn't find a way to establish a relationship among the numbers. And then we went to the books. And so we really dig into we took our time, and we have arrived to the answer, well, at least for 90 degrees. This seemed impossible. This seemed not technically possibly possible for us. Some other people say, "Yeah, this guy does not know anything about trigonometry." Uh, this guy is lost. He has no. Uh, he has no way to do this. He will quit. We'll stick with the task. Uh, Now look how beautiful this looks like. And it is the same image. It's a straight edge. A not B, but A. Uh, it is uh, what it should be because we marked the lines. That was the intention of it. Imagine having this a little bit off. We will say, "Oh my God, no!" And then we will be in trouble. We will say, "Oh my God, now what we are going to do?" But look at this. How beautiful is this? With this, I was never feel. I feel happy. I can close the live stream right now. But since I am donating 2 hours for this thing, I am taking 1 minute break, 2 minute break, and come back for a 45 degrees rotation, 45-degree rotation. And if it works, then we are going to refactor the code for reuse, extracting functions. Now that will be live coding. We will be extracting functions. We will creating functions to say, okay, this is the first quadrant, and it behaves like this in the components of the coordinates right here in this quadrant. So in this viewport, this one, quadrant one, quadrant two, quadrant three, quadrant four. So in these, the two components are positive. In here, there is negative x and positive y, minus x, y, and here is minus, minus, and here is positive x, minus y. So why I'm saying this? Because 90 degrees is here. Or unless we find 90 degrees and draw the image, uh, if we find 90 degrees and draw the image in the way the canvas works, it will be start here and it will end here, right here. So we needed to find this opposite, if you will, here, and then draw the image because that's the constraint of the viewport. Now we are going to try 45 degrees. We will draw, we will make the draws. We will be making drawings and see how the components will behave, maybe another angle, and then come up with a function to tell us uh, the sign of the components. And once we have 4 rotations doing performed, once we have performed 4 or 5 rotations on different angles, uh, then we are going to take care of this guy, the button, some sort of slider, some sort of text area. We don't want to go crazy here. It will be amazing if we do it with the scroll of the mouse. But remember, this is for mobile devices. First, mobile first. So they need to have something over here. And in reaction or in response to these events, perform the rotation. So we will be working on this application at least for this month, I suppose. Especially if we are doing a lot of something, like I tend to do. But I don't want to be just doing things. Then why go live? I don't know. I have seen people doing that, and this is great because the main thing is the job they are doing. What I want to talk, I want to. I don't know how to shut up. I wish I can shut up. Okay. Okay, button. So with some sort of user interface component, and then do the thing. Maybe we will try some other coordinates. Right now we have 90 degrees here. Uh, we are going to do 45 degrees coming up, and then move this thing over here and do 60 angles, 60 degrees angle. Then move over here and do 80, 180, some some silly uh, angle, and then go with the UI component. Maybe tomorrow. Not today, no, most likely tomorrow. Unless we are really going fast. But I'm pretty sure that will be the case because we are still making sense of how the viewport behaves in terms of the coordinates. Remember, we have just learned about the trigonometry of rotation, which is beautiful. This can be animated. This can be animated. Now we can draw a clock here. Uh, every second move an angle. Now we can do some animation with this center of rotation. I'll be right back. Don't get disconnected. Let us see if there are people. Six. We have two live viewers. I'm sorry, guys. Uh, I need to go and drink some water. I don't know if you are able to say hi. So we have 100% here. One like. So there are people seeing this. I really need to drink water. I'm sorry. I'll be right back in 2 minutes, 3 minutes, maybe. You can leave if you do. Thank you very much anyway for your time. Okay, you're back. Maybe we'll be here for another hour. Only 60 people have left. And there is one. Live viewer. Okay. This YouTube should have a sound when some live viewer enters and stays for 10 seconds. There should be a sound so people can say hi. You know, they are the masters of the development. These Google guys. Okay, let's try. We can comment all of this, but let's try 45 degrees without taking care of this component that most likely will punch us on our faces in the face because we haven't made any uh, calculation. We even don't know how it will, the kind of result we are expecting. Before, okay, so this is the thing, and we rotated 90 degrees, 90 degrees. So we ended here. So 45 degrees should be here, like this, in the middle of this, some sort of. But it will be wrong because the negative coordinate that we have, in fact, we're wrong. We're going back to 90 degrees and explain the reason. So this is 90 degrees, but it's not here. The 90 degrees is not here. This is 270 degrees. 90 degrees is here. 90 degrees is here. And then we went here. So 45 degrees will be here. And then we need to find this to draw the straight edge at 0, 0. So we need to find the 45 degrees. It will be here. Then we need to find its counterpoint. We are going to name it like that. And it is negative x, negative x, negative y. For 90 degrees, we have negative. We were lucky. We have only negative y. But for in here, we neglect both. Okay, so 45 degrees is here. The rotation ends here. And we need to find this guy. So again, 45 degrees. Oh my god. Okay, we are going to fix this thing. Okay, maybe we need some drawings. I think this is wrong, but I don't know how to prove it is wrong. If we draw a circle, this seems to be okay. Mm, mm. This seems to be okay. Mm, something like that. But in here, I'm not so sure. Let's draw a perfect circle. I cannot. This cannot be. I'm not sure. I'm not sure about this. This is wrong. This should be a little bit aligned with the other 1690. Okay, it feels wrong. It feels incorrect. Let's do some drawing. Mhm. Okay, so okay, we're going to use Google for the coordinates. Okay, so let's suppose now I understand why they are so eager to use a unit circle. I was thinking, what's wrong with these people? Why the unit circle? Uh, so this is 1, 0, and 45 degrees. It's here. We don't know. Uh, so XY, and its counterpart, it's right here in the middle. So this is 90 degrees. If this is 90 degrees, then this is 180 degrees plus 45. and this with this. Uh, this is the angle 125 plus 45 plus 90. Yes, this is the angle 100, 240, 225. And in here, this is minus x, and this is minus y. So we are doing it in the we are right in the sign of the coordinates. So something does not feel like correctly. This is minus x minus y at 125 degrees. And we have something wrong in the car. We know. I have now. I know. Let's go back to. Mm, we're going. No, we're going to reward the 90 degrees so we can see why we didn't go with 270, which was a shortcut that now we are paying uh, the thing. Mm, look, this is 0, 1. In this coordinate system, or in the viewport, we wanted in the viewport, in the viewport 90 degrees is over here. So in the viewport, this is 0, 1 because since it is mm, x remains the same since it is a 90 degrees rotation, even if it was the line over here, x will remain the same. So we were able to have the shortcut. So for the viewport is 0, 1. For the viewport is 0, 1. But then for the viewport 90 degrees is here. So we were able to say, okay, x, where is x, plot x, remains the same. And we didn't move anything. But y gets negative. And we were able to do this. This is a negative sign for 1. And then we draw the straight edge. We are starting from the negatives. We are starting at this guy, not in 90 degrees. So let's adapt. Now we are going to use the concept of counterpoint. And if it was 90 degrees, we need to find its counterpoint. We are inventing this. This is from music. At least in Spanish. Okay, counterpoint. But and this is not related. Maybe not. I don't remember. I read this many years ago. Always. So we are using the concept here since we are ignorant of the mathematic terminology. Eventually, I will find the right name for this. So this is the counterpoint, 260 degrees angle. We are using only 360 degrees rotation. If the user wants to go crazy and wants to perform 1,000 rotation, we will say, you don't do that here. It's the same. Uh, that sort of rotations, the big numbers, are, I think, are suitable if you are doing some sort of animation, if you're doing some sort of maybe a toy that you in the past do things like this, a number of rotations, and then the thing it gets wrapped. Then you need these 1,000 rotations. That 1,000 angles, so you can spend some duration of that rewinding this. But for us, it's not necessary. Okay. So now let's use the concept of counterpoint. For 90 degrees is 170. We should be able to use 170 and have the 90 degrees rotation effect, the perpendicular uh, straight edge. So for that, let's try. Let's try it like this. We are finding the this guy. We are not finding this guy anymore. We are going right directly here, and then rotate 90 degrees and see how it goes. And look, it is the how to say this? This is what we said early. This is the 90 degrees. Uh, this is 90 degrees. It's here. We need to go here because now we found these guys. It should be uniform. But now it is not aligned. Okay, so we are going to uh, adapt all the whole framework. We are coming with a framework in here, so not desperate. Uh, and now that we are here, this is related. This is because the look at this. Probably we will need to get rid of this extra thing here as extra haste over two. Well, let's wait. And now we're going to find 45 degrees, which is here, and its counterpoint, quote unquote, will be 225. And actually remains the same, but let's try negative. Yeah, X remains the same. So let's try this guy. Well, now I'm going into tinkering again, and we need to clarify our minds. Now we are again crunching numbers, and that's why it's not working because we are not understanding anymore what we are doing. We are just again going blind. But mm, we are going to get there. So I would like to work first these 45 degrees, and then going with the 90 degrees that we almost have. Uh, Well, we need to adapt that 90 degrees to the counterpoint concept or counterpoint frameworks that we need uh, some more drawings. More drawings. Okay, then take a deep breath. And oh my god, we have this. This should be negative. And we have again this little bit, this offset should be here. I think we did have this early with the 45 degrees. No, we did have much. This, if we rotate now, there is something in here. There is a point over here that is, well, if we rotate 90 degrees, quote unquote, we will have this, there, this distance will exist. Oh my God. I think we're going to get rid of this. Now we have maybe, but there is a little bit of an offset. Look, but it's like a pix at the pixel level. I'm not sure if you're able to see this. It is at the pixel level. And then we have this, which was our positive marker. I don't know about this. These are the pixel level. Maybe 1 pixel. Uh, okay. So what do you think is happening here? I think it's with the cosine and sine, maybe. Well, I don't know. It feels a little bit weird. I'm not sure if this is at the center. So the moment of truth is with this guy, which is 45 degrees. Mm, okay. So we will have trouble here. We are in trouble. Mm, um, we need to fix this. It work for 270 degrees. Okay. We will need to really work these examples. Let's see. This is why is this? Is this why? Yes. I don't think this is correct. I don't know how to make sure. I don't think this is correct. Maybe that's correct. You know, let's go back. Let's go back to the drawings. If now we're going to use the viewport orientation. This is 90 degrees. If we find this guy, if we find the, oh, this will take like more 3 hours because we're going to work with the unit circle. To the only way we need to corroborate or verify this is with the numbers, with the coordinates in the unit circle. This figure, this drawing is a little bit mess. It's a mess. It's messy. It's not perfect. We are not able to see if the things are aligned. But if the numbers are correct, it doesn't matter if the drawing looks a little bit off with an offset because uh, the the thing found the correct numbers. But anyway, if we if we find this point or this, then we will say 270 degrees. If we find this point and rotate 270 degrees and draw the figure at 0, 0, it should behave like this. But we need to translate here. Okay, we found, oh my god, we most likely found this guy. I'll translate over here. I'll translate here. Let's not rotate to see if the drawing starts here. So it finds it is. I'm confused again. Oh, we are messing with this. Okay. So now let's rotate. Why we are not negating anymore? Uh, why we are not negating this radius? Because we found this point, but then we rotated. Uh, we find this point, 90 degrees. We translate over here. Now okay. But, if we rotate, look, we're here. If we rotate 90 degrees, the thing will look like this. It goes over here, and it goes over here. First, it was like this. This is X, and this is Y. X, Y, X, Y. I hope it's clear for you. But we have rotated. This is 90 degrees. Well, we have rotated, I see 90, okay. Oh, this is hard. Oh, this will be, okay. This is the normal thing. So if we rotate 90 degrees, it will be like this. This will be X, and this will be Y. And if we rotate 180 degrees, okay, now it will be like this. But this will be X, and this will be Y. We have translated to this part. If we rotate 90 degrees, it will be like this. This will be X, and this will be Y. This is X, and this is Y. I can go directly to 270 degrees, but I want to see how it looks 180 degrees. For X, Y. So this is 90 degrees. Mm, and I want to see 180 degrees. I think it will be like this. This is X, and this is Y. Now the other one, the 170, will be this. If we use the arrows for X, and this is the normal arrow, this is the 90 degrees, then this, then we have the 80 degrees, And then we have this guy, and now we have the entire plane. Okay, no, that was silly. Not silly. That was a little bit challenging to see. Uh, they- mm, 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 mm. Okay, so we have our drawings complete. Okay, so we can use the eraser. Okay. Oh my God, almost the 2 hours with this. So we rotate now without the negative uh, trick of the signs. We went here to 90 degrees of the viewport. This is the 90 degrees of the viewport. We are here. With this, we were able to find these two right here. And the thing it seems aligned only by one, so off topic. Offset. And that is acceptable for the time being. Then we can work the millimeters or pixels or whatever as we made some addition here. So we now have rod X and rod Y here on the 90 degrees. Then we rotate the viewport 270 degrees. Now the thing goes crazy like this. And you saw the effect. And then we draw the threaded edge A at 0, 0. And that's why it's starting from here to over here. And we have the marker. This is positive X. This thing. We are starting from here. This is positive X in the normal view. And then we are at 90 degrees here from this thing. Yeah, from this radius here. Rotate to the counterpoint, 270 degrees. And then draw. And it did something like this. Or whatever you want to draw. And this is a positive marker. And it works for 90 degrees. So now let's use 45 degrees. I'm not sure how it should look like, honestly. So both of these are positive. And then we have this thing that seems almost to work, but I don't know why it's not working. I don't know why is the gate that is not working. I don't look. I don't. I don't like how it looks like. It seems like it is missing something, some sort of midpoint. I'm not sure it's on X and Y. Actually, probably only on. Let's subtract. Uh, So this is the positive marker. We will need to work the 45 degrees in the drawings. I don't want to do this tinkering, tweaking. It seems like we need to subtract from x. Mm, this is so it will be minus x. I'm not sure if this is correct. This is 45. 50 with this. 60 with this. It seems a little bit correct. It seems acceptable. But I'm not sure. We are going to need to see the numbers behind the calculations, the results. Um, 16. Okay. Oh my gosh. I'm not sure if this is correct, honestly. It seems so, but I'm not sure. Besides, the 90 degrees could be wrong. Well, we can make an if condition here. It doesn't matter. But I would like to know if the others are correct. Let's try 50. will be maybe this. I'm not sure. I'm not sure. I'm not sure. This is scary. It seems to be correct. It needs to be correct because we are working with the same center of town. It should be correct. We're going to check the results of the cosine and sine with the unit circle. Let's try uh, this guy. Now we need to take care of this. Um, for for uh, for 90 degrees, it was 270. It should be 290. But remember, uh, 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 it seems correct. But this thing is not, the center of point is not, something is wrong with the radius, with this. We're going to check out. And, okay, now it should be, okay. I think here it's obvious. Oh my god. So the market ended in the same spot. And she'll be here. Well, we have something wrong. Because if we have this arrow at 0, 1, and rotate this, we should end here. Now the positive sign, if you will. I suppose there is a line and there is also marker here. Should be here, and it should be -1, 0, and in here it should be 1, 0. So something is wrong with our rotations. Something is wrong with our rotation. Something is wrong. Now say here. Oh my god. So now we're going to turn 180. And if it look like this, yeah, I know where this thing is wrong now. When we have 90, we have uh, this guy. We're going to move here. 100. Forty-five degrees was this. So we are moving over here. So at some point, those 80. And yes, it's really, we are right. So we, we are We are here. And then we find 180. For 90, we found this guy. 45, 110, 180. We find this guy. We find this guy over here. Oh my god, I need more dragons. So we were here, then we find 90 degrees, and then we translate over here, and we have this guy, this screen, this viewport. Then rotate 180 degrees, and we have this. Okay. Well, now we're here. We find this guy and we translate over here. It should be something like this. This is X, and this is Y. If you rotate 90 degrees, yes, this is Y. It should be like that. Because if we do 180 degrees, it will start from here and we'll have this thing will be here. You see? Now the marker is here. Okay, we did this. And now we can see that the sort of offset, which is a little bit silly. You know why? I'm not sure if the rotation moves. I don't sure if the if the rotation translates the thing. But according to the documentation, in order you need to translate first prior to rotate. Almost likely this thing is moving, and now it's obvious that we need to add or subtract uh, -5. Most likely add. 10, which is the midpoint. But this thing moves. The center of rotation is moving. Mm, the center of rotation is moving. Another 6. Oh my God, I don't know what numbers this maybe X minus X. So we need to rely on the calculations. One very well documented circle is the unit circle. Uh, so we're going back to the line. No, not to the lines. Um, and check the calculations. And if the calculations are right, well, it doesn't matter if the thing is moving. The I will definitely rely on the trigonometric functions. Well, there is the thing of the flat numbers in the computer, the storage of flat numbers, the storage of flat numbers, flat number arithmetic. And I would rely in the functions instead of the visuals, uh, because we will not have to strategize to see uh, that there are no. Still, a user can move the slider over here very quickly, rotate like this. Look at the cursor, and the strategy will translate in the rotation. It will rotate and translate, and it will be obvious. But then we can add a note. These are the calculations of the trigonometric functions. We are not tweaking the numbers because then we will be at the same point, uh, trying to come up with a relation with the offset, right? Oh my God. We say 2 hours. We can be half an hour extra. Okay, let's get rid of this and redo all the work, rework all the things. So now we're aligned. Let's try the unit circle. Well, the unit, this is another. The unit circle is its radius, this one, not its diameter. And if we make this too small, we will not be able to see. If we make this thing one pixel. This is very well documented. Everything will be here, and if our calculations find these quantities, it doesn't matter. Then if the thing is translated, we will say it's the web browser or it's the Canvas or JavaScript or whatever. Okay, for the unit circle, its radius is 1. Okay. Well, this is silly. Doing this is silly. We can really calculate even in the console of the web browser. Um, yeah, really, it is. We are not drawing this. We are going to start with 90 degrees, and we're going to use the unit circle, and maybe this. Maybe we need to store this. I'm not sure. Most likely not. If this thing works, then we are going to say, okay, plain JavaScript. Not JavaScript because the results are right. So we can or bear with it, deal with it, or stick to it. I don't know. Uh, Cosine or like X component. For 90 degrees. Oh my god, now what? Okay, let's find this guy. Oh, on computer science, Emory University. Okay, so where's the image? Okay, here it is. So for 90 degrees, it will be pi over 2. I should know this by memory. Why could it be the case that it is adding some numbers? Okay, why is one? This is great. So why is one? And there's something. Oh my God! There's something wrong in here. I'm not saying. I'm not saying it. It should be zero. It should be zero, but it's six. Uh, it should be zero. It should be zero. This degrees. Radians. What is this number? Very different than six. Still, this is too much because the image was working. You see, the image was working. You saw. Oh, this is wrong. X should be zero. XX should be zero. The radians or degrees. And this is very complicated since it returns the cosine of a number in radians. A number representing an angle in radians. Okay, I should also know this. Radiance, okay, blah blah blah. So first is this. So let's check this 1 point. This number one. We need this point. We need this number. Why is this? What is it? Oh, this is also. Mm, oh my. So this is right. 1.50. 1 point. How can I say? 1.5707. 1.5708. Mhm. Like, and then the X, I don't like the X. We need to store this. Now I want to solve this problem. This is wrong. This is wrong. Let's see. So it has to do with the floating point numbers. Okay. What's wrong with this? Uh, is the library cosine uh, uh, defective? This is wrong too. And uh, this is the number given by Google. Well, it should be zero. This is zero. Number name zero. It says zero, and it's here, almost zero. Approximately zero. So there's something wrong here. But JavaScript does not have. Uh, let me still, at this one point, whatever number this is way different than six. One has to do. Oh, but it is still to the minus 17. So probably this is zero approximately. This is one. So let's try another angle. And let's try 180. So for x, So for X is my okay, now cosine is working. The cosine works. And but this guy is zero because of the minus 16. I don't know why. And this is pi. This is pi 3.1415. This is pi. And it's here. This is pi. Look at this. I know that number in the past, but it always comes with different presentations. But I memorized this 3.1415 and then all number in the past. Yes. I don't know why teachers, or I mean the education system wants for the children to memorize that number. I mean, 5 digits, it's okay. Well, thinking a person is smart because it memorized a lot of the decimals is not. It's not healthy. It's only good memory. Uh, that's not mathematics. So cosine works. But now is there's okay. It's okay. So we need to store the radians. We're going to store the radians. We are going to store the division. We are going to see if this thing we have over here, this formula, uh, there is some precedence in here. There is this multiplication going first, but maybe, I'm not sure, this goes first, this division. So we need to see that we got this from the internet. Uh, then I derived the thing in my notebook in some previous exercise, but I didn't memorize the thing. I can derive the thing again from the figures, and that's not memorizing things. That's recomputing. You are saving memory by recomputing, or your memory is getting skewed. In Burrito's world, they're destroying people's memory capacity, memory skill. So they need to start to really uh, memorize some elements and then recompute and recompute and recompute, which is the principle of these digital computers. If you lack memory, then you recompute. If you have too much memory, then you go and grab the data, which is what the kids do when they're in their, how do you say that in English? 10 times 1, 10 times 2, 10 times 3, things like that. They don't, at the beginning they count, then they compute, then they memorize. So we are not getting crazy about this. We are seeing the mess that, the mess the JavaScript has with the plotting. It's not JavaScript, it's a big time field or topic in computer systems, plotting numbers. Uh, what else we can do? We will need to add the slider and we will do fast moves with the slider and see if the thing is too crazy, we will need to at least smooth the thing. If the rotation is, if the translation with the rotation is very obvious, very aggressive, I think we will need to take a look at that. I don't know if this goes first, so let's find out on the internet. Most likely here. It should be here. Degrees. There's no degrees here. And I cannot see this because it's a white page. I need to the dark theme over here. So maybe these guys need add some dark theme. You know, this is a university. Come on, let's put some student that wants to want some credits. I don't know. What's this? Come on now. Just keep in the form. So you think it doesn't matter? Let me remember. Because I experimented with this, if the division goes first and the multiplication when doing the variable thing. So no parentheses also. And then again they multiply and then divide, so it's okay. So no parentheses, it's okay. So let's we see that cosine we have this number. Let us try more numbers before leaving this topic. We are not complaining about this. This is cool. So we saw that number one for cosine works, number one for sine works. So let us write. Oh my God, this guy, which is one half. This is 60 degrees. Oh my God. 60 degrees. This thing. Okay, 60 degrees. And then 3 hours of guitar now. Yeah. Okay. 0.5. This is great. Again, some pi number here. Over 3 most likely. Oh my God. Um, so this is 0.8. This is, I remember this number. It's this. Let us see. I don't think this is okay. Pi over 3. No, it's the other one. Oh my God. Uh, square root of 3 over 2. Mm. Okay, so I remember this. Okay, so it works. The library functions works. Degrees. Remember, we were trying to actually make a addition of this arc to reach this arc. We were very naive with our approach, but I feel good anyway. You know, we say we are at 30, we need 60 degrees, and we were finding that these things switch. Look at this one house and this one house. Square root of 3 over 2, square root of 3 over 2 over 2. This is at the center. Look at this, you know, you see? And we saw this pattern. Oh my god. So 30 degrees. So it will be the same things but switched. Okay, and here is 5. And maybe you want to do this even with mathematics. That this number eventually will become 5 is and the limits, you know. And then we have this guy. I don't care about this not being zero point 0.5, honestly. I have seen some YouTube videos in the past that they demonstrate that 0.9999 is 1. And then we have, where is this guy? So this is pi over 6. So the radians work. And the radians work. And the radians work. And the radians work. And the library, math library works. So I don't know why this thing is not working. Let's try again. Now we see that the unit circle is called radius was correct. Remember, we print all of these at the beginning. Yeah, what's the other? Okay, we are saying this. It will be aggressive, the translation and the rotation. Well, we still need only one of these, just in case you're having a little bit of difference. This is okay. It's only one. And maybe this. We're going to get. We're moving things. Nothing happens. Now we're getting rid of this. It will be a mess. Look, I would like to understand why. I would like to understand why that was the case. But it's quite obvious. Remember, we have the x. This is x and this is y plus the midpoint, which is here. Oh my god. They had a lot of this. Oh my god. Oh my god, there's a lot. Radius. Radius. And we're also going to print this. Radius. Last. Just to be. Well, that will be with or two. Okay, it works for 90 degrees, if you will. I'm not sure if this is correct because this is the positive marker. And if we rotate 90 degrees, the people would like to see this over here instead of here. Because you can say the people, well, in the Canvas technology, in the API for Canvas, the specification says that the coordinate systems are uh, top-down. You know, these people are regular users. You don't get to request them to become that technical, to go that deep into the details of technology. Um, they will say it needs to be, they don't need to know about this. It should be uniform, the experience for them with other applications. And with, especially if these are students, they will say, okay, this guy is going backwards, and my book says that 90 degrees is up there. Well, this is quite right. But I think we got it right. I think we got it right, with the exception of the 180 degrees. We can add an if condition to that. Look, for the user, and if they are these kids from high school students or elementary school, hopefully, for them, this is the first quadrant, this is the second quadrant, this is third quadrant, and this is the fourth quadrant. So if they're seeing this with this positive marker over here, and they say rotate this thing 90 degrees, I think we got it right. They indeed will expect to see this marker over here. So we are right. So it was a rotation. So we got it right. But 45 degrees, which is a little bit silly, is moving. Uh, we're going to do some drawings. For 90 degrees, it was almost correct. I don't feel that good about this guy. 1 pixel. That is acceptable. But at some point, the thing becomes crazy. Maybe someone in the comments can help. Well, we need to move, especially because the drag and drop will be challenging the drawings, and then we can come back over here. We are not spending the entire year with these details. Let's finish this and then focus on the details. So this is 90 degrees. Uh, well, for 45 degrees, we got it wrong. The thing should be like this, and the marker should be here. You know, this reminds me of a song by Final Fantasy that is called An Arrow Through Time. I'm going to listen to that song right now. We got around this 45 degrees. This is 45 degrees. This is 45 degrees. This is 45 degrees. But we have some we have something like this. Let's do 45 degrees. Remember this arrow. Remember this arrow. This is 45 degrees. I don't need to do the 90 degrees thing because you know, 45 degrees. This is wrong. This is wrong. The marker should be here. So we were lucky. We were lucky with the 90 degrees for the people to see. Uh, how do you say that? This marker, positive marker over here, right? But now for 45 degrees, which is here, because yeah, actually, I don't think I'm getting uh, those DC or no, not DC. I'm very healthy. Very confused. I'm getting confused. So for 90 degrees, we did have this. Oh my gosh. For 5 degrees, we have this line. Mhm. And 90 degrees is here. And 45 degrees is here. 45 degrees is here. Well, the user will say, come on, this is not 45 degrees, this is 100, 135 degrees. 90, yeah. If you present this to the user and he write here 45 degrees and you do this, the user will say, come on, what's wrong with this guy? He wants me to learn now the Canvas API specification, which is good if they will become software developers, JavaScript developers. Well, most likely they will be doing some other things, some other careers, which are very important. But the mathematics will be with them for their entire lives, according to Elephant. This is wrong. So what can we do here? Remember, I cannot believe this. Okay, for 90 degrees, we were lucky. We calculate this point, which is 90 degrees. If the center of rotation is this, and if we agree that the radius is this, and the positive direction with the user is very acquainted, goes like this on the x-axis. So we were lucky, and then we calculated this. Look at this. We calculated this point. We translated the point over here, the origin over here. We rotated 170 degrees and we draw the thing. And we were happy. But now the user wants 45 degrees. And if you present this, they will say, this is wrong, this is 135 degrees. No, so let's not. Well, what do we need to do here is to move this guy over here. And for that to happen, we will need this guy. Tomorrow we are going to calculate these relations. And then Okay, for 90 degrees, we have this guy. And for this, well, it will be like this anyway. So it will be, we are here in the same spot. So this point, this rotation will be 170, which is here, plus 45 is 350. 350. And it's quite possible because we are moving toward 360 over here in the top-down coordinates. So let's try this. 135 and 350. Yeah, and then we have this, which is 45 degrees. Now, I think we have made it. The problem is that and the problem is that this offset, I don't feel quite uh, content with this. I would like to ask in some forums on mathematicians because I don't want anything to do with floating point numbers. If this is related with this, I don't care. I'm accepting this offset. But if I only care if it's related with mathematics, that I'm not applying some formula by right. Mm, maybe the radians, maybe some division over here. Maybe the center of rotation is miscalculated. But it is, if someone comes to me and saying it's because this, okay, then it's beyond me. I don't. I have a book that deals with this, but it's not. And someone will say, then you are not into writing high quality products. Well, I am, but uh, I don't know how we are going to fix this floating point numbers unless we uh, write some approximations, some mappings, or some tabular data with the offset over here. It can be done, but I want to finish the application and then focus on these details because this is too much. It moves too much, and we will see tomorrow that when we move the slider, it will be moving. It will be obvious that there is a translation in place when you are doing the rotation, and it should look like a clock. Like these little handlers as you see in the clocks, in the walls, on the walls. And here, thing will move. It's okay. It's not okay, but we can deal with that at the end. And probably make questions in the forums. And it will be documented if I make a question in Stack Overflow or any other forum. You will see. I will not ask the question and say, hey, I find the answer. I'm not like that. So let's see if this is right. It should be this. It's um, it is expected if you have uh, 135, and so it's minus x, y, and it is in the middle. So it is it is uh, it is the same number. There is a one little offset over here. Yes, there is a little this thing. There's something wrong with but that's on the libraries because one is cosine and the other is sine. Unless I don't think that this little fellow is not too much. I don't understand why it's moving. Can we do this? I don't think so. Where is the result? Okay, here it is. So it's look at this. I don't know. So the calculations are right, but the image is moving as you're seeing. The coordinates are well calculated. The math is working. Okay, let's try another angle. But it will be a thing of mapping. It will be, oh my God, it will be a matter of mapping the angles uh, with the respective sides. But I don't like this, to be honest. I don't know why it's moving. Let's do something natural for but still. Let's use 45 degrees everywhere. Okay, now there is some relation with this. Remember, it was minus positives. Now the two are positive, uh, and it gets switched. Now, if we do an exercise, if we move this in our minds, some parallel translation, they say in geometry, and move the thing over here, do you think this point will end in this point? Now, this is natural. This is, we are not doing anything weird in here. I don't know how to make this. Maybe with some sort of an instrument. Oh, there, where they are. Okay, show ruler. This thing does not have the concept of negative and positive. Okay, reach 90 degrees and start to decrement. This is a good solution. And this thing does not move, so it's possible to solve this. Okay, the thing got moved, even in its natural. Uh, okay, so there, the thing, what I wanted to show is that we are not making any crazy movements. We are going all 45 all the way. 45, 45 everywhere. And still, there is a little bit of offset. This, uh, this point should intersect this. I mean, those lines. Like, maybe there is something here. This point, there is something here. You see? There, we need to add that space. But I don't know why is the case. I would like to understand why. I don't want to. Now that I'm doing this, there you go. Look at this. Now the screen has crazy. It's crazy again. Okay. So this is X, and this is Y. In order for this to move on this, because I want this to, it's just like a line, like this sort of line. I remember from the few mathematics that I know, that if there is a plane, each one of these, there is 1 point here, 1 point here, 1 point, 1, 1, 2, 2, something like that. So we will go adding one to every component. Then again, here we need to subtract from both components. -1. Maybe it's not even here. Mm, Now the screen is messing with me again. Okay, this is the thing. I think this is acceptable. Plus 30. Plus 30. Is to and subtract. Something like this. And which angle is this? If 130, if 135 or 45, is this like 15? But look, these numbers will be fluctuating from zero. Um, I think it uh, minus 10 to 10, which is the width, the height of the straight edge. What will be 160? What will be 60? 60, 45. 120. 45 degrees. You see, 90 is 120. Um, Oh, okay, that's great. Let's suppose this is 16. So that would only mean that this is 120. Maybe 13. 300. Here we need to. I don't know. I am unable to see if the X. Uh, um, if the X is in the right spot, but obviously the Y needs to add some numbers. Maybe we need to come up with an image that make in which we are able to see uh, these little lines. This should be some sort of transparency. As I was telling you, this is great. This is 60 degrees for the user, for the use from the user's point of view. For our service display, we need to do some mappings. And in order for the thing to not be that aggressive, these numbers will be fluctuating from, I think, from 10 to minus 10, or from 0 to the absolute value of the height over 2. If we are able to find a relation defining this rotation in this event, that will be amazing. So why is this thing moving? But it will require a lot of hours of observing and experimenting. And I think we need, I would like to move. Tomorrow we will try with another image and let us see. We will try a little bit, uh, some sort of an image that allows us to see both images, markers, both images, marks, and if it is not so obvious the fluctuation in the numbers in the offset, then we will add this control to see how aggressive is the translation in relation to the rotation. That will be some calculus. I have seen graphics like that in which you have a circle and then there is another line describing a movement of translation. Oh, I wish I have studied mathematics in this way in the past. But in very that world, studying mathematics was very dangerous for citizens. In very that world, the state was detecting smart people, uh, especially the ones engaging in mathematics, so they can kill them or screw their brains so the apparatus becomes smart. That's the only way. That's the only way the apparatus uh, will have worked for in that science fiction world by eliminating the smart people or the curious people, inquisitive persons, things like that. And mathematics is a way to spot that guy. So it was very dangerous to study mathematics in that world. Quite a dystopic world, quite a nightmare. And the people collaborating with these companies, with these corporations, with these, they were, from my point of view, from the point of view of the narration, they were like vomit, like scumbags, uh, uh, enemies of the human race, actually. I don't know. That's why, thank God, we are in this reality in which that cannot happen, and we can enjoy mathematics, and I feel relief. You know how alleviated my spirit went when I say, thank God that's not happening here. Uh, I feel really happy and relieved for that not be the case at this time. Oh my God, I feel relieved, really. And uh, amazing. You can do mathematics. And that's why I'm building this. So people can do some geometry. It will be not perfect. You're seeing now the details. But then again, it will be only to just draw some lines, mark some points, build some triangles, for me to share some lessons from the book, based on the book by Helfan and Alexeyskaya, uh, his wife. I don't want to call her his wife. She existed by herself. So it is by Israel Helfan and Tatiana Alexeyevskaya. Uh, Great book. They nailed it. I will sharing some ideas from that book using this software, and I hope someone will be happy doing geometry in the way it should be done for the first time, in my opinion, for entry level people in this field. Oh my God, what a relief. And I need to say goodbye for the time being. We got it here, and we also nailed it. We have the opportunity to find this relation in this offset. It should be entertaining. Uh, yeah, have a good one. I need to play the guitar. Thank you very much. We were here for where is this thing anyway? 3 hours and 40 minutes. Oh my God, I was intending 2 hours. Then I said we can go for 2 hours and a half. But this is you can spend your lifetime with these lines and see, hey, why it's not behaving in the way it should. I would like to say this honestly tomorrow. Before tinkering with the numbers, we will implement the slider, and then we'll see the funny movement, the funny translation with the rotation. That will be funny to see. I would like to see that first, and then yeah, maybe we can draw some lines, and then try to find what's going on here because it's also entertaining. Uh, what is this? All right, so I'm going to play the guitar. I need to really constrain myself to the time because now I heard my programming for myself. Some Java refreshing. Java. I like to dig into some Java topics, some particular areas of Java, Java, of Java. That's what happens when you want to sound cool. You end saying something like Java instead of Java because you want to sound so cool, too cool, so knowledgeable. You are levitating and you are, oh my God, let me study Java. All right, have a good one.